Okay. Hi, everybody. Come back. We have to restart it. Shake my hand. Yes. Hi, everybody. Okay. First rule of public speaking, make sure the audience is awake. Okay. So I'll try to go a little fast because we are behind the time. And I'll talk about technology, the future of work, related to supply chain. So first of all, AI and technology, of course, is not new. Supply chains are automating very fast, whether it's warehouse automation or autonomous vehicles or risk management. We'll talk about some of these. There's a lot of new AI applications to risk management, especially in procurement. When we go to retail stores, we see that they're automating fast. And of course, demand forecasting. The reason for being, or the main application of AI is demand forecasting, or forecasting in general. The whole issue of AI is seeing what's ahead. So we talk about some type of forecasting. We talk about autonomous vehicle. You like to see what's ahead and so forth. But when I give this talk, the main issue is, what about my job? I mean, generative AI is coming for my job. AI is coming for my job. What happened to my job? So let's talk about job disruption. How does job disruption happen? What's the process? So there are actually three basic processes. The first thing is de-skilling, and we'll go over each one of them in more detail in a minute. The first one is de-skilling, requiring less expertise, and also, unfortunately, in many cases, leading to lower pay because the work is simpler. The next step is scaling or augmentation, is equipping the operators with tools that make their job easier, faster, whatever, but also is tied to reducing the number of workers, because fewer workers can do the jobs, can do the work in less time. Finally, there's some elimination. Some jobs do go away, and we'll talk about this. So what do you mean by de-skilling? Some examples, the loom, 1804, making textile. In the UK, the beginning of the 1800s, we had the punch card. This was the first use of punch cards, instead of artisans and master weaver going and operating the loom. So it could run basically automatically. Once you had the punch card, you could do the same pattern over and over again. You didn't need master weavers to do it. The assembly line, instead of a group of workers putting a card together, have the assembly line, and the job became very simple. It simply do the same thing over and over again. By the way, as an aside, if you were in the early talk, when David was talking about Amazon and bringing the job to the workers, that's exactly what Henry Ford did, almost 100 years before that. Instead of the workers going to build the car, the workers stood by and the car came to the workers. That's the same principle, basically. Numerical control machine, of course, simplified work. And I like this example. How many people have been to London? You have not been to London, you should go. It's a nice city. Okay. Looks at me like, okay. If you go into a black cab, driving a black cab used to be an expert job, because you needed to get a license to drive a black cab. You needed to know every street in London, every point of interest. You need to have to go in the shortest way from everywhere to everywhere. It took 4 years of studying, and then what people call the toughest test in the world to go through it. And it started from the horse-drawn carriages. To operate those, you needed to go to the same test. So what happened with technology? Google Maps and Uber came in, and now everybody can do it. You don't need to study. Google Maps, Apple Maps, they tell you all the point of interest and where to go from everywhere to everywhere. It's even better because they give you real-time congestion. So the job was de-skilled. By the way, as an aside, used to be about 28,000 cab drivers in London. Now there are about 8 to 10,000, but there are tens of thousands of Uber drivers. The ultimate de-skilling is, of course, let the customer do it. We don't need the, make your coffee by yourself. Self-checkout at the supermarket. Automatic teller machines. We don't need tellers. You can build your own website. There are so many tools today to build your own website. So basically, we move the work to the customers. They do the work. It's the ultimate de-skilling of jobs. Scaling means augmentation of doing more with less. And that's true in every type of work. You have machinery that help you do the work. You have all kinds, whether it's a warehouse worker or construction. If we talk about agriculture, for example, it started from something like this. Lots of people working in the field, and then with horses and with the tractors and combines, and now actually with autonomous combines. They do everything by themselves. The impact of this, as an aside, was in 1900, 41% of the US population was employed in agriculture. At 2000, it was less than 2%. It's now about 1.5%. So we saw a huge reduction on a countrywide of people employed in a profession, yet there was actually no massive unemployment. There were other jobs that came into the fore. Some jobs were eliminated. That's true. We don't have any more elevator operators. We don't have any more exchange operators, people you call and they connect you. We don't have any more computers. Computer used to be a job description. Companies were full, there's a room full of women, always women, they're much better at math, doing financial statement and doing accounting, bending by hand before spreadsheets. This went away. Computer is now a device. Telegram messengers, cockpit crew. Used to have 5 people in the cockpit. Now there are 2, and we are about 3 or 4 years away from having 1. The other one will be an AI system. And we were, by the way, depending on them. There was in 1945, there was a strike of elevator operators in New York, and New York shut down because all the big office building, people were afraid to go and operate the elevators themselves. They were so used to operators. The successful implementation are robotic process automation, things in the office, whether it's call centers or compliance reporting or order processing. A lot of the things that do not involve the machine making physical movement. So things that are just happening basically in the back office. And some of this is quite sophisticated. There's a company nationwide in the US, insurance company. You have a problem with your car, you have an accident with your car, you just take a picture, and several pictures, and you send it to them. 80% of the time, it will be solved without human intervention. It will understand, it knows the car, it knows the, your account. It will tell you how much it's going to pay and send you to a garage to fix it, give you option of several of them. Another thing that take place is translation. Translation is becoming better and better. And a colleague of mine, wrote a book about trade, and the quote that I like from the book is, "Increased trade enabled by machine translation is equivalent to cutting the distance between countries by 37%, which means countries trade a lot more when they can communicate, when it's easy to communicate. Let's explain a little bit the difference between what you might call traditional AI and generative AI, just so we know what we're talking about. So traditional AI systems are very good at pattern recognition. So I have a colleague of mine at MIT who's very successful in detecting breast cancer from images. She used to train it on images in MGH, Massachusetts General Hospital, and she is now not better than the best radiologist, but as good as the best radiologist. And in many cases, she can discover things earlier because of the pattern. So pattern recognition is a very powerful tool. Generative AI, however, creates pattern. Not only recognize existing pattern, but creating new patterns based on the training data and in a probabilistic way. So some examples. So traditional AI does a lot of the things that we see today, whether it's trading on Wall Street, whether it's dynamic pricing, when you go to when you fly and the guy next to you is paying half what you paid for the same seat, for the same flight. Of course, demand forecasting, all kind of chess playing Go. All of this is what you might think is algorithmic AI or traditional AI. Generative AI is different because it can generate text and images and music, videos, new drugs. A lot of the pharma companies are using generative AI to come up with new drugs. Computer code, we know that computer code now, simple computer code, can be generated by ChatGPT. What are these? These are actually de-skilling activities. Instead of having an expert write text or a talented photographer take a picture and manipulate it, ChatGPT or other program can do it. So it's we're basically de-skilling creativity. So let's look ahead and see where we are heading, or we might be heading. So we talk about what about my job? Prediction are all over the place. And by the way, we will come to this. Example, Oxford, well-known university, came up with prediction that in 2013, 10 years ago, they said that 37% of US jobs will be eliminated today, by 2023. Reality, employment in the United States, unemployment is an all-time low, the percentage of working is an all-time high, miss it by 120%. Totally missed it. So take predictions, including mine, with a grain of salt. Job disruption is a very slow process. It does not happen overnight. So there are many hurdles to eliminating job, to total automation. For example, the first thing that you might think is public acceptance. Today's jetliners actually can go gate to gate without a pilot. They're actually drones. The 777, 787, A350, they're basically drones. I don't want to embarrass everybody. Who will go on a flight across the Atlantic at 35,000 feet at an aluminum cylinder that doesn't have any pilot in it? Not too many people. In the same vein, people may not feel comfortable of having large trucks driving at 100 kilometers an hour on the highway right next to them with nobody on board. It takes used to, and it may never happen. We see a lot of the problems right now with cars, autonomous driving in San Francisco and elsewhere in the United States. The second one is regulation. In 1584, a guy by the name of Williams introduced what's called the stocking machine. It's a machine that made stocking, basically. He brought the stocking to the Queen Elizabeth I, and she almost beheaded him because she was afraid that the machine will eliminate jobs and create a problem in the UK. So she disallowed, the machinery. Finally, the labor unions, of course, their reason for being is protect job. And they all, many times, will be protecting jobs and working against automation. Throughout history and throughout all the industrial evolution, one thing is clear: more jobs were created than destroyed. Now, in many cases, it's hard to know which jobs will be created, and the anxiety is understandable because you know the people are going to lose their job. They're the people in the supermarket, in the bank. You know the people. What you don't see is the new industries and the new jobs because they didn't happen yet. And we can talk about examples. I'm running out of time, so I don't want to do too many examples. One thing I'll tell you. Ford, when it came up with the assembly line, went from about 10,000 workers to 150,000 workers at the height of the Model T. People think, oh, create a lot of jobs. That's nothing compared to the fact that cars became less expensive and people develop highway, hotels, motels, restaurants. The whole hospitality industry developed with tens of millions of jobs. Henry Ford did not intend to create the hospitality industry, but it happened sideways. That's why it's so hard to predict what will be the impact of technology. And humanity has a role here. People live in the physical world, and they understand context, which for machine it's hard to understand. They understand surrounding. They have a moral code, which ChatGPT does not. They have ability to deal with unexpected challenges totally outside what the machine was trained on. The machine can interpolate, but it cannot create a totally new stuff. And of course, creative drive, we can invent new stuff. And the thing that's very applicable to procurement, it's unlikely that if you are trying to contract with a new supplier in China, Indonesia, somewhere, you just send some code to the supplier and they'll send your code back. No. The way it works, and it's likely to work in the next, 10, 20, 30 years, is that you have to fly there, you have to negotiate like crazy for 2 days, and have dinner together and talk about your kids and talk about your family and become friends. That's how business is done. So it's not going to replace quickly. And of course, there's a question of risk tolerance. The machine may have some recommendation, but we know if we are going towards a recession or something else, and the calculus will change. People will start buying totally new stuff rather than the old stuff. So just modes of working together. How can machine and people work together? Because this is the challenge in front of us, making people and machine work together. So one way is that the machine analyzes the data and people make decisions. That's a classic procurement application. There's quite a few procurement applications, both procurement and risk management, to scan a large number of suppliers, understand new suppliers, understand who they are, and vet them. But doing it at scale with tens of thousands of suppliers very quickly. System being monitored. So for example, the standard way of automatic ordering is something go to the point of sale in the supermarket. It checks an item went out, the inventory is checked, goes to the computer, and orders being generated. But understanding that if there are, for example, I mentioned the example before. If there's a recession coming, we know that patterns are going to change completely. And we cannot do ordering, and there are many examples of this. One of the jobs in the future is monitoring, the main future jobs. So chatbot, for example, you used to talk to a customer service representative, you used to press 1, do this, press 2, do this, press 3, do this, until you got frustrated. Now, you talk to a machine, and the machine talks back to you until you get frustrated. So you get frustrated. In the US, you start screaming, agent, 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 and somebody comes on board. Sometimes the machine itself recognizes it doesn't know what it's doing, and a human comes on board. But this means monitoring. Somebody is sitting there and monitoring the situation, which is a tough job, actually. Sometimes control go back and forth. I mentioned the example of Amazon. Stuff comes to the picker does stuff, move, another stuff comes. Operating robots, whether it's a manufacturing floor or running drones. And augmenting, whether it's exosuit or robotic process automation. So generally, generative AI should be used with care. The machine tends to hallucinate, invent stuff that doesn't exist. It makes mistakes. It is subject to all kinds of catastrophic failure. Even Google went down one day. And it's subject to cyber attacks. By and large, it cannot do complex stuff. So if you look at something is less stable and kind of what we call VUCA, volatile, uncertain, ambiguous, and complex, and the use of AI, it usually go like this. Current AI cannot deal with something that's complex, stochastic, and not deterministic, despite what vendors will tell you. So finally, be careful with using generative AI. You use large language model, your data become part of what other models will be trained on. So you have to do what's called a sandbox. You have to put walls around it. Make sure that the data is in good condition before you do anything. Something that David mentioned before, attack specific issue where you understand the problem. The idea of what's your AI, what's your generative AI strategy is a stupid question. It's like, what's your mathematics strategy? I mean, what do you mean? It's a tool. So you should develop solutions for specific problems that you understand, not to large-scale solutions. The idea of tell me how to run my supply chain kind of doesn't work. Very important not to make decisions that involve the physical world by AI, because it can be dangerous because of the mistakes. And finally, this is the basic downside of large language model and the new generative AI. You don't know how to fix it because you don't understand the solution. You don't understand the algorithm. If you want to convince yourself, try to put the same query in ChatGPT time and time again. You'll get different results because it's a probabilistic process, which means when something goes wrong, you cannot trace back the algorithm and fix it. This is how algorithms are becoming, all kinds of algorithms are becoming better and better, because the computer science can go in, find out what's wrong, why did this statement say this, should have said this, and fix it. Very hard to do with large language model. Anyway, let me stop here. This is some of my other books for those who are interested. And if you're not interested, I pity you, but it's good. Have a good time, guys. Thank you.